An operating system is the system software that manages resources of computer system and provides an interface for interacting with computing components. There are two main resources that a user program or application software need to make use of. These are memory and CPU. Operating system of the computer has to reside in main memory along with other programs, and it has to manage main memory for programs and schedule CPU time for different processes or programs present in memory. In this video, we are going to discuss memory management. In later videos, we will discuss process management and CPU scheduling. Idea of multi-programming and time-sharing system was developed with operating systems use of CPU and main memory. Multi-programming is the technique of keeping track of multiple programs in main memory that are competing for the access to CPU for execution. Multi-programming, hence, is achieved by operating systems memory management function. In time-sharing environment, CPU time is shared among multiple interactive users at the same time. Time sharing by operating system is achieved by CPU scheduling and process management. Although users work on the same system, like a workstation, but the operating system manages resources so efficiently that user has illusion that they are working on their dedicated machines. Memory management, in essence, is the act of keeping track of how and where programs are loaded in main memory. For this purpose, memory is divided into chunks of space known as word. Size of word is in the powers of 2, for example 8, 16, 32, and 64, etc. Each word of the memory has unique address. To store a program and its data in memory and keep track of data in memory, we would need physical or actual addresses in memory where a program or data is stored or is going to be stored. So how exactly operating system decides where in memory a program is going to be stored? Data to be stored from program has logical addresses. These logical addresses are converted to actual or physical addresses in memory. To understand this concept, we will have to define logical and physical addresses. But before defining logical and physical addresses, understand that program and its data is stored in memory, and memory in different computers has different physical addresses. So if a program made a reference to same address in different computers, it won't be able to store or access its data. So a logical address is a reference to a stored value relative to the program making the reference, and a physical address is actual address in memory. To get the physical address of a specific program or data in memory, its logical address is added to the starting address of the program. So a starting address where a program is loaded is important to determine where in memory a program's data will be stored. When a program is loaded into main memory, logical addresses are mapped to the physical addresses by the operating system. This process is called address binding. We will discuss three ways by which memory is managed by the operating system. First one being single contiguous memory management. In this technique, program is loaded into continuous area of memory available beside operating system in main memory. Here, beginning address A is the last address of operating system in main memory. A user program will start loading from that address, so physical address of the program will be beginning address A plus the logical address of the program. Second technique to memory management is dividing memory into partitions for storing multiple programs at the same time. There are two ways memory can be divided into partitions. Either divide memory into fixed number of partitions or divide it according to the size of the program being loaded. In this technique, information of starting address of partition is stored in base register, whereas information of length of current partition is stored in bounds register. There are three strategies for allocating a partition to a program in partition memory management. First strategy is first fit, which means allocate first partition big enough or large enough to hold the program. Second strategy is the best fit, which means allocate smallest partition that can hold the program. First fit and best fit are both used with the fixed partition technique. In worst fit strategy, largest partition is given to the program. In dynamic partition technique, this strategy will work because unused portion of partition can be assigned to another program. Logical and physical addresses are determined by the same method discussed previously. But before a program is assigned a partition, logical address of the program is checked. If logical address is less than the address in bounds register, that partition is assigned to the current program. So if a partition is selected, physical address is obtained by adding beginning address present in base register to the logical address of the program. In paged memory management, processes are divided into fixed size pages and stored into frames of the memory. Keep in mind that a process is the program in execution state, so it can be any part of a program that needs to be stored in memory for execution by the CPU. A process is divided into pages that are same size as frames or blocks of storage in main memory. A page map table maintained by operating system keeps track of page frame relationship of each process that is stored in main memory. The biggest advantage of paged memory management is that process no longer needs to be stored contiguously in main memory. Pieces of programs can be stored anywhere in memory. A page map table to the right contains entries for a page number and the frame number in memory where that page is stored. Theoretically, all frames are same size, so a frame may be, for example, 256 bytes, 512 bytes, or 1024 bytes in size. A logical address or the address of the page in this technique is written as page number, offset, where page number is obtained by dividing the address by the size of the page, and offset is remainder obtained by dividing the address by the page size. For example, a logical address of 1250 with page size of 512 bytes will be written as 2,226 or 226. And if you want to convert this logical address into physical address, according to the page map table on right, we can see that page number 2 is stored in frame 4 of the memory. Let's assume frame size is 512 as well. So physical address will be frame number multiplied by frame size plus offset, that is 4 multiplied by 512 plus 226, which is equal to 2274. Paging can allow us to keep main memory free by only bringing pages from secondary memory to main memory when they are needed for execution. This feature of operating system is known as demand paging. It is achieved by swapping current page in main memory with the page in secondary memory. Using this method, operating system can create virtual memory for faster execution of a program. However, this method has a downside as well. Excessive page swap, also known as thrashing, can reduce the overall performance of a computer system. That's all in this video. Like and subscribe to watch more and learn more.